Okay, good morning everyone. This is a slightly new setup because I've got a new computer. So I did not realise that my face would be on show. But hello. You actually see a face rather than just a voice talking over the video. I'm Miss McLeod or Laura. Because you're year 10s, I know that you go by first names normally for teachers. So today we are going to look at graph skills. So the learning objectives are to define dependent, independent and control variable. We are going to identify dependent and independent variables in an experiment, and you are going to be able to draw a fully labelled graph with a line of best fit, and you'll be able to calculate the gradient from a graph and interpret trends. The gradient we might look at later on because that is a more complicated concept, but we'll see how we go. And the keywords, we've got dependent variable, independent variable, and control variable. Those are key ones for this lesson. So you'll know what each of these mean. Average, line of best fit, and trend. Okay, so let's have a look at these variables then. So the independent variable is the variable or factor that is changed during the investigation. So that is the one you change. The dependent is the variable that you measure. So if you were to investigate temperature, with temperature being the independent variable, the temperature would go along the x-axis of a graph, and then whatever you're measuring would go on the y-axis of the graph. And the control variable or you can have more than one control variable. They are the ones that you must keep the same to ensure the experiment is a fair test. Okay, so now let's have a little think about some examples then. So here we've got an investigation to see how the solubility of salt is affected by temperature. So you'll need to identify the independent, dependent and control variables. Remember, there might be more than one control variable for this. I will give you, pause the video here and take a minute to think about it, and then we'll go through the answers. I will highlight which bit the independent variable is with different colours. Those are the colours that I'll go for when we go through the answers, but just take a minute. Okay, so hopefully you have paused the video now and you have thought about which variable is which. Okay, so investigation to see how the solubility of salt is affected by temperature. Let's start with the dependent variable, since this is the colour that I've got. So the dependent variable is the variable that you measure, and the independent one is the one that you change. So the one that you're measuring is the solubility of salt, and then the one that you change is the temperature. So that's your dependent variable. Your control variables could be anything really. The same amount of water. Let me try and write. Water is the same in the beakers, and the same instruments are used throughout. The same type of salt is used. Just anything like that, anything that you can think of like that. Okay, so here we've got another example. So an investigation to see how the strength of an electromagnet changes with the number of turns on the coil. Okay, so I'll give you another few seconds to think about that. And I'm going to colour code, however, choose the highlighter, colour code these. Okay, so the one that we're changing, which would be an independent variable, is the number of turns on the coil. And the one we're measuring is the strength of an electromagnet. And then your controls could be anything from the person turning the coil, so making it tighter, person conducting the experiment altogether, and the type of electromagnet used, just anything like that really that you can think of. Okay, so here we've got an investigation to see how the concentration of an acid affects the speed of its reaction with magnesium. So the one we're measuring, which is the dependent variable, is the speed of its reaction with magnesium. So that is the one that we are measuring. And then the independent one is the concentration of acid. So we are changing the concentration of acid during the experiment to see how it affects the speed of the reaction with magnesium. For controls, you'd have to keep the magnesium the same. So make sure that you use the same amount of magnesium on each one, so you'd weigh it beforehand. Also, you need to have the same volume of acid and the same timer, and ideally the same person carrying out the experiment as well. Okay, so I've skipped forward a few slides because there were quite a few of those examples. I didn't need to go through them all, so hopefully you've got the idea there. So let's just go through the results tables. So results tables always need units. You must include units when you do a results table. So that is very important. I'm trying to highlight in one straight line, but it's not letting me. And then you've got the independent variable, and that usually goes down the left-hand side of the column. So there. That is your independent variable, that's where that goes. So it will go down here. And then you've got your dependent variable, which is here. And remember, that is the one that you measure. So you would have to take multiple readings, which are called repeats, to get an average, and also you can identify anomalous results as well for doing that. Whereas if you just take one reading, you don't know if that is the usual result that you would get for that experiment. Okay, so I'm just going to let you think about some types of graphs that you probably learned about before. There are, I think there's 5 that I'm looking for here, so I'll give you about 30 seconds to have a think about that, and we will go through it in a moment. Okay, I'll give you about 5 more seconds to have a think about that. Okay, so we have got a bar graph, a pie chart, a histogram, and a line graph, and a scatter plot. Okay, so have a think about which one you might be asked to use in science. There are 2 in particular that I'm thinking of here. And if you just saw my pointer, I actually did just point at them. So if you were on the ball there, you would have seen me point at them. But just have a think about which 2 we might use in science in general. We wouldn't use the other 3 normally. Okay, so if you saw me point at them, would it be in this one, the bar graph, and the scatter plot? Because there are 2 different types of data that you can get. You can have continuous and you can have discontinuous. I'm not really sure quite where to write it. Contin and then discon. Okay, so you've got discontinuous data and you've also got continuous data. Now, discontinuous data means that you can easily show it in a bar graph. So this one here, put a star on it. So that would be things like height of people, if you were measuring the height of people and comparing it to others, age ranges, as we got here, we've got years, months against temperatures. Apologies for the really bad circle that I just drew there. So you could have months, age ranges, heights. The other one that you could have is eye colours and hair colours. It's just set data ranges that you can easily compare to another one. Now, you would use scatter graphs for every other data set that you have, because you can easily see, you can plot the points clearly, and you have the x-axis here, and then you have the y-axis here. So you can then draw a line of best fit as well, which you can see here. That is your line of best fit, and that goes as much in the middle of all of the points as possible. So that is for every other bit of data that you would record. You would use a line graph, well, not a line graph, a scatter plot with a line of best fit. Okay, so we looked at tables earlier, but on graphs you also have simple rules and similar rules. So you've got the dependent variable, which is on the y-axis, and then you've got the independent variable, which is on the x-axis. The x-axis is the horizontal one, and the y-axis is the vertical one. Now, your dependent variable is the one that you change. So the one that you measure is your independent one, and that goes along the bottom. So if you're measuring temperature, that would go along the bottom. If you're changing temperature, that would go along the bottom. If you're measuring it, it would go along the side. So if you're changing that, it goes along the bottom. Okay, so here is how you would plot your points. So you would have your, as I said earlier, your independent one here and your dependent one here. And then you would plot your points clearly and as accurately as possible, and you would draw a line of best fit, which is basically a line through as precise as possible through as many points as you can draw it through. So you can also have a line of best fit through curved data sets. So here we have a slightly curved data set. I should maybe point to it with my mouse rather than with my finger, because you can't see my finger. So you can have a curved data set here, and you would just free draw that. With the straight line ones, you would use a ruler. So what do you think is wrong here then, out of this graph? If you pause the video here and have a think about that. Okay, so the main points I wanted you to pick up on here was the fact that the scale is so large, but that's just the data set down here. So the scale of the graph is so large in comparison to the size of the data set that it is hard to actually analyse this data. So what you would want to do is, because the data only goes up to sort of 9 or 10, you would want to stop the graph here and then maybe go down to there. So that's between 60 and 120, so maybe about 90-ish. So you'd want to have the scale going from 0 to 90 on the x-axis, and then 0 to 10 on the y-axis, because that will show the data more clearly and you can analyse it more easily. Another thing that is wrong here is, where is the title? There is no title here showing or telling us what this graph is showing. So you need to have a title. Okay, so there is no title. There's also no units. I'll write them here. There's no units on the y-axis, and there's also no label on the y-axis. So these are crucial points that you need to include on every point of a graph. So let's put y there. I think that's the main parts really. So you need to include a title, units, and a label on each axis. And weirdly, the units are included on the x-axis, but not on the y-axis. So, oh, and also scale. Scale is a very important thing. Make sure your scale is right, otherwise your data will be quite hard to read, not unlike my writing with this mouse. Apologies again. So what does a perfect graph need then? So you need to have a useful title, a sensible scale. The axis has to take up at least half of the page, because otherwise you are really squinting to see that data and to see that graph. You need to have labelled axis, both the x and the y axis need to be labelled. You need to have units on each axis and also in the title if applicable. You need to have clearly plotted points, so normally plot them with a cross, like so, and make sure they are as accurate as possible. You can align your points with a ruler so that you can see where you're going to plot the point. And you need to have a smooth, accurate line of best fit. Again, if that is a straight line, use a ruler. If it is not a straight line, it is a curved line, freehand it, but do it in one smooth stroke. Okay, so now we are going to play Spot the Mistake. So I'm going to show a graph and you have to try and spot what the mistake is on the graph, and I will talk through what is wrong with each and how to correct it. Okay, so there are a few things wrong with this graph. There are 3 or 4 things I'd like you to pick up on. So pause the video here, take notes, and I will show you the answers afterwards. I will edit this PowerPoint and then talk through what I mean after that. Okay, so these are the points that I came up with, which I was drawing as I paused the video there. So the student has put resting heart rate on the x-axis and hours of exercise on the y-axis. Now that is actually incorrect because the hours of exercise would be your dependent variable. That is the one that you are changing because you are actively doing that. Your resting heart rate is the one that you are measuring. So that is your dependent variable and therefore goes on the y-axis. So they need to be switched around. One arrow there. There we go. Also, the person appears to have drawn in pen. That is a big no-no. Do not draw anything in science in pen, especially graphs, because if it goes wrong, you can't rub it out, and it doesn't look as neat either. Another fact is that the points seem to be randomly placed. For example, this one here is not really a clear point, and neither of these ones here. They're not in a set place as such, and that could be down to the scale that the student has chosen. So the scale, you can actually start at 45. So you can start your scale at 45 and then go up in 5s up to 90 because it stops at 90. That is the last point. And I guess that is it. So what I'll do is I'll make the adjustments on this graph and then I'll explain what I've done and how it will change the look of the graph. I do not have a ruler on this screen, so my line will also be wonky, or I will not draw a line. I'll just explain you will draw a line through these points, but you'll get the gist of it when I draw it out in a different colour. Okay, so here I have edited this. Hopefully you can see it, but I'm going to explain it anyway. So I have put beats per minute on the y-axis. So that is here. That is beats per minute on the y-axis. And then I've put exercise on the x-axis. And I've also put exercise and then hours in brackets because hours is the units that is used in this. So obviously it would be heart rate and then beats per minute in brackets because that's the units, but I can't write sideways very well. I can't write at all very well on this computer, so I just put beats per minute down there just to signify that. And then I've also changed the scale slightly, so I've got 2 to 20 going up in twos, increments of twos on the x-axis, and then on the y-axis I start at 45 and then I go up in fives up to 90, and then I have plotted the points sort of vaguely where they would be plotted, and your line of best fit would go straight up the middle, straight down the middle or up the middle, and you would use a ruler for that. So you would get as many of these points in the line of best fit as possible, and then that would show that. So there's your data set. That is what I just worked from. And we just looked at that together. Okay, now it is your turn to have a go at a graph. So let's just go through it together. So you'll be given some data from an investigation into the speed at which pepsin breaks down egg white at different temperatures. Pepsin is an enzyme, and that breaks down protein. And it can be affected at different temperatures. For example, denatured. It can be denatured at high temperatures. You'll then be asked some questions about the experiment and its results. So I'll just go through this information quickly. So a scientist wanted to see whether temperature affected the speed at which pepsin, which is the protease secreted by the stomach, digests egg white. They set up 4 test tubes and put egg white, hydrochloric acid and pepsin into each one. Each test tube was placed in a water bath at different temperatures, and the students timed how long it took for the contents of each test tube to go clear. Here is your data set that you will need to use. You'll have access to this anyway, because I'm going to put the slides on OneNote, which you should all know how to access now because I've put plenty of instructions up. And you can also pause the video here and jot down the numbers. So you've got temperature in degrees Celsius, goes from 10 through to 45, and then time taken for mixture to go clear, and you can see that there is a clear trend going down, and then it rises again after 40. So think about why that is, thinking about enzyme properties and temperature. And the second part that we're going to talk about a little bit today is how to interpret graphs. So you interpret graphs describing the general trends and patterns, starting from left moving to the right of the graph. Don't use the words line or graph because that is clearly shown by the graph. If it is a line graph, you can see it's a line graph. You do not need to say this is a line graph showing. Use the axis labels in your descriptions. For example, the death rate increased, and then use examples. So for example, X amount. And then pick out notable unusual features, notable or unusual features. For example, maximum values, points, patterns that don't quite fit, which are also called anomalies, and general patterns and trends. Also quote numbers, as I said earlier, just give examples that clarify your descriptions, and use describing words such as increased, decreased, constant, maximum, sharply, slowly, fell, or rose. Those are good describing words for describing and interpreting graphs. For example, this is the first question on the sheet that you've got. So an oyster farmer has been keeping records of the water temperature and the number of oysters developing from 200 fertilised eggs. A graph of the data is shown below, so that is here. So you've got number of eggs on the y-axis and the water temperature in degrees Celsius. So your dependent is on the y-axis and then your independent is on the x. So you need to go through what the independent and dependent variables are, the optimum temperature, and what the graph shows. So describe what the graph shows. I can't move my little picture, that's annoying. So as the water temperature increased from 15 to 30 degrees Celsius, the number of oysters developing increased steadily from about 70 to a maximum of 140. So that is the sort of description that an examiner or I would look for in an answer to these questions. You've also got above 30 degrees Celsius, the numbers developing drop steadily, with none developing at 50, or between 30 and 50, the numbers developing drops or decrease steadily from 140 to 0. So you can see that they're quoting the numbers from the graph and giving examples as well. So this is the first question for the worksheet that we just looked at, and there will be a link to this worksheet in the description box below. And I will see you next lesson. Hopefully it's not as data heavy as this one.